Ever felt overwhelmed by performance-based questions on your CompTIA A certification exam? You're not alone. These hands-on simulations are the #1 reason many test takers struggle, but today, that changes. I'm going to walk you through realistic scenarios from the Core 1 exam, showing you exactly how to approach each one with confidence, not just what to click, but the actual thought process that will help you succeed on test day. Ready to master these simulations? Let's start with a Workstation Configuration challenge. This simulation tests your ability to configure a workstation for video editing. While there may be different ways to analyze and approach the problem, we need to identify the specific combination of components that best meets the requirements. First, let's understand what we're trying to build. The scenario describes a video production company needing workstations for 4K video editing. Our key requirements include multiple 4K video stream handling, real-time effects rendering, color correction capability, fast timeline scrubbing, and dual 4K monitor support. Let's analyze each component's role in meeting these requirements, starting with our processor options. We can choose from Intel i3 3GHz, dual core with 4 threads, Intel i5 3.5 GHz quad core with 8 threads, Intel i7 4GHz octa-core with 16 threads, or Intel i9 5GHz 12-core with 24 threads. The Intel i7 4GHz octa-core provides the optimal balance here. Its 16 threads enable parallel processing of multiple video streams while maintaining smooth, real-time effects rendering. For system memory, we have these choices: 8 GB, DDR4 2666 MHz, single channel 16 GB DDR4 3200 MHz dual channel, 32 GB DDR4 3600 MHz dual channel, or 64 GB DDR4 3600 MHz quad channel. The 32 GB DDR4 3600 MHz configuration provides the sweet spot, enough capacity for complex projects, while the dual channel configuration ensures optimal memory bandwidth. Looking at graphics options, integrated Intel UHD graphics, 4 GB GDDR6 workstation graphics, 8 GB GDDR6 professional graphics, or 12 GB GDDR6 enterprise graphics. The 8 GB GDDR6 professional graphics card meets our needs without overspecing. It handles multiple 4K streams while providing hardware acceleration for effects. For display configuration, we can select from single 1080p professional monitor, dual 1080p professional monitors, single 4K professional monitor, or dual 4K professional monitors. We'll select dual 4K professional monitors as explicitly required in our specifications. For storage, here are our options: 500 GB SATA solid-state drive at 550 megabytes per second, 1 TB NVMe Gen 3 solid-state drive at 3500 megabytes per second, 2 TB NVMe Gen 4 solid-state drive at 7000 megabytes per second, or 4 TB NVMe Gen 4 RAID 0 at 14,000 megabytes per second. The 2 TB NVMe Gen 4 solid-state drive provides the optimal balance of speed and capacity for handling multiple 4K video streams. For the motherboard, we can choose between H610 with basic PCIe 3.0, B660 with mid-range PCIe 4.0, Z690 with high-end PCIe 4.0, or Z790 with premium PCIe 5.0. The Z690 motherboard offers the necessary PCIe 4.0 support and robust power delivery for our components. For power supply, we can select from 500 watt 80 plus bronze, 650 watt 80 plus gold, 850 watt 80 plus platinum, or 1000 watt 80 plus titanium. The 850 watt platinum power supply ensures stable power delivery with enough headroom for intensive workloads. Finally, we need to enable several key features. We'll turn on graphics processing unit hardware acceleration for faster rendering, multi-channel RAM configuration for optimal memory performance, high-performance power profile to maintain consistent processing power, and PCIe Gen 4 mode to maximize component communication speeds. Before submitting, let's verify our configuration. Have we met all video editing requirements? Are our components compatible with each other? Have we enabled the necessary features? Is each selection justified by the workload? Remember, you can use the reset button if needed and return to this question later. Take time to understand each requirement and how the components work together to create an optimal video editing workstation. Now let's move on to our next simulation, which tests your troubleshooting skills. In this scenario, we have a graphic designer whose workstation is experiencing multiple issues after a thunderstorm. Let's first understand what we're dealing with. Our system shows 3 distinct symptoms. System fails to power on self-test, random blue screens throughout the day, and no signal on the 4K monitor. These problems started right after a recent thunderstorm, which is an important detail that might point us toward power-related issues. When approaching troubleshooting scenarios like this, it's crucial to consider both the symptoms and their potential relationships. Multiple issues appearing simultaneously after a specific event often share a common cause. Looking at our available solutions, we have several options with different priority levels, checking power supply voltages and connections, testing RAM with diagnostic tools, resetting the graphics card and checking its power connections, updating graphics drivers, and trying different display port cables. Let's solve this methodically. Our first and highest priority symptom is the system failing to power on self-test. Given that this started after a thunderstorm, we should first check power supply voltages and connections. Power issues can cause not just startup failures, but can also affect system stability and display output. The random blue screens could be caused by either power issues or memory problems. Since we've already identified potential power supply issues, let's make testing RAM with diagnostic tools our second step. This has priority level 2, as memory issues could explain the system instability. For the no display output symptom, we have 2 potential solutions. Resetting the graphics card and checking its power connections is our next step, with priority level 1. This addresses both the display issue and potential power-related problems. Updating graphics drivers or trying different cables would be lower priority steps, since we likely have a hardware-related issue given the thunderstorm context. Remember when troubleshooting to, first, identify all symptoms. Second, look for patterns or relationships between issues. Third, prioritize your solutions based on both symptom severity and potential root causes. Fourth, start with the most fundamental components, like power supply, before moving to more specific solutions. Take your time to analyze each symptom and consider how different solutions might address multiple issues at once. In real-world scenarios, efficiency in troubleshooting comes from understanding these relationships and prioritizing your approach accordingly. Let's move on to the third simulation, where we need to configure 2 printers for an accounting firm. This scenario tests your ability to balance regular office functionality with security requirements. In this case, we have 2 distinct printers to set up, a main office printer for general staff use, and an executive printer specifically for confidential financial documents. Both need to work with the existing network infrastructure, but they have different security requirements. Let's start with the main office printer. For the connection type, we have USB 2.0, Ethernet at 1 gigabit and wireless options. Since this is a shared printer in a business environment, we'll select Ethernet at 1 gigabit for reliable network connectivity. For paper size, we'll choose letter as it's the standard business format. The printer supports multiple options, including letter, legal, A4, and envelope, but letter is most appropriate for general office use. Looking at print quality settings, we have draft at 600 dots per inch, normal at 1200, and high at 2400. We'll select normal at 1200 dots per inch, as it provides good quality while maintaining efficient printing speeds. For the main printer options, we'll enable duplex printing to save paper and job accounting to track usage. Economy toner mode isn't required as it might compromise print quality. Now for the executive printer, which handles confidential documents. Again, we'll use Ethernet at 1 gigabit for the connection, ensuring stable and secure network connectivity. Paper size remains letter for consistency across the office. While this printer supports additional sizes like A, 3, and executive format, Letter is our standard choice. For print quality, we'll select high at 2400 dots per inch, as this printer handles important financial documents that need to be crisp and professional. The executive printer security options are crucial. We'll enable duplex printing for efficiency, but more importantly, we need to enable secure print, network encryption, and user authentication. These security features ensure confidential documents are protected throughout the printing process. Before submitting, let's verify both configurations. Main Office printer has duplex and job accounting enabled with standard quality for everyday use. Executive printer has all security features enabled with higher print quality for professional documents. Both are using Ethernet connections to ensure reliable network integration. Remember, when configuring Office printers, consider both functionality and security requirements. The Main Office printer prioritizes accessibility and usage tracking, while the Executive printer emphasizes document security and print quality. Moving on to our fourth simulation for Core 1, we're going to configure expansion cards for a workstation. In this scenario, an engineering firm needs several hardware upgrades. Let me show you what we need to do. Reading through our scenario, we can see that each workstation has 4 expansion slots on its motherboard. The firm needs better network connectivity, high-quality audio for conference calls, and support for 2 high-resolution displays. We need to choose which cards go into which slots while watching our power and speed requirements. Let's start with our graphics card. Looking at slot 1, we see it offers 16 lanes of bandwidth, perfect for our graphics card that needs high bandwidth for dual displays. I'll click here and select the graphics card, which uses 175 watts of power. Next, let's look at slot 2 with its 8 lanes. This is a good spot for our audio card. Even though it only needs 1 lane of bandwidth, placing it here gives better spacing between cards for cooling. I'll select the professional audio card from the drop-down menu. Moving to slot 3 with 4 lanes, this is where we'll put our network card. It has both wireless and Ethernet capabilities, but only needs 1 lane of bandwidth and uses 10 watts of power. The location works well for the wireless antennas too. We can leave slot 4 empty since we've placed all our cards in optimal positions. Take a look at the system status display below. Notice how our total power usage stays within limits, and our bandwidth is properly allocated. If you need to try different arrangements, just click the Reset Selections button at the bottom of your screen. Alright, let's tackle our 5th and final performance-based question, and it's a good one. BIOS configuration. In this scenario, we have some fresh workstations that have just arrived for the development team, and we need to get their BIOS settings dialed in for optimal security and performance. Let me guide you through this, step by step. First up, let's head to boot configuration. Here. We need to set the boot sequence correctly. It's all about putting the boot options in the right order. You always want your primary drive, which is the SSD with Windows Boot Manager, at the very top. This ensures that the computer boots correctly when using that drive. Use these up and down arrows to move it to the top of the list. Next, we'll place the USB drive second for recovery options, followed by network boot in case we need a PXE, and finally the DVD-ROM at the bottom. That's a logical order that sets you up well. Now let's take a look at Secure Boot. This needs to be enabled as it provides essential security and Windows 11 compatibility. For quicker startup, we can keep Fast Boot enabled too. Alright, next let's switch over to processor settings. Here we need to enable Intel virtualization technology. This lets the dev team use their virtual machines, which is crucial for their work. While we're here, go ahead and enable hyperthreading for better multitasking. For CPU performance mode, setting it to balanced will give you excellent performance while keeping power usage reasonable. Next up is memory settings. For improved performance, we're going to set the XMP profile to profile 1, 3600 MHz. This optimizes memory usage for those dev tasks. The memory operating mode should stay at optimal. This setting doesn't usually need any changes. Now for something really important, security settings. See TPM state. That needs to be set to enabled. This is needed for good security and Windows 11. And to keep your system safe, let's not forget the administrator password. Set something that you'll remember but is also hard to guess. Finally, in system cooling, let's make sure the fan speed profile is set to performance. This is going to ensure that these machines are kept cool when the development team is really pushing them. The CPU fan mode can stay on auto, it will adjust as needed. Oh, and if you ever feel like you've messed up, no worries at all. Just use the reset to default button down at the bottom, and you can start fresh. And that wraps up our deep dive into setting up the BIOS for optimal security and performance on a new workstation. I hope this walkthrough was helpful and gave you some clarity on those tricky BIOS settings. If you found this video informative and useful, please consider giving it a like and subscribe to the channel for more CompTIA A+ PBQ walkthroughs. Up next, we'll be tackling the Core 2 performance-based questions. Keep studying smart, and I'll see you in the next one.